This lesson demonstrates the use of an affine transform to not only translate a figure from one location to another, but to rotate the figure. Oh, by the way, I've heard this pronounced affine, and I looked it up in a couple of dictionaries, and one said it was affina. But I'm Southern, so I'll just go by my instincts and say affine. Now this paint method draws two figures. The first one is translated from its position at the origin, and the second is left in its position at the origin and rotated 45 degrees. This method does the translation. It moves the figure from its origin at 0, 0 to a point at 20, 20. The affine transform is then set into the graphics 2D object before the figure is drawn. Here, a new affine transform object is created, and this one is set to rotate by 45 degrees. The angle is actually specified in radians, so 45 degrees is written as pi over 4. Here's the output. See, the translation works just fine. The figure is moved from its origin point in the upper left-hand corner out into the window where it can be seen. But the other figure is rotated in place and is mostly out of the window. But it's possible to have a single affine transform perform both of these operations. In this example, only one figure is drawn. The affine transform is initialized to do the translation of the figure by moving it out of the corner. Then this call is made to the rotate method to add the instruction to also have the figure rotated by 45 degrees. Now here's the result. Now there's one very important point I need to make here. This figure was first rotated in place and then it was translated out into the window. If you'll take a look at the source code of the program, you'll see the object is first set to translation, then set to rotation. Now this is important. The affine transform will do things in the opposite order in which the instructions are given to it. And this can make a big difference in the graphics it produces. Let me show you an example that demonstrates this difference. Now, this example paints two figures. They are both translated and rotated by 45 degrees. The first figure is set to translation first and rotation second. This one is filled with a solid blue color. Now this transform is set to rotation first and then to translate the figure. And this one is filled with a solid red color. Note the different names for the methods. The set2 methods initialize the entire transform to do only this one job. The simple command form of the method name, without the set2, concatenates the new transform information with the information already stored inside it. Because of that, in this example, the same affine transform object could have been used in both of these operations, but I separated them to make things as clear as possible. Now the blue object was first rotated in place while it was still at the origin in the upper left-hand corner, and then, after it had been rotated about its center, it was translated to its position in the middle of the window. On the other hand, the red object was first translated to the location out in the window, and then it was rotated around the origin. If you look at the surface on which the red figure is painted as a sheet of paper with a pen at the origin in the upper left-hand corner, then the paper was spun around the pen by 45 degrees, putting the red arrow where you see it now. The blue arrow was spun around the pen while it was still in the upper left-hand corner, then moved out into the window. But always remember this. If you set an affine transform to perform operation A, then give it instructions to perform operation B, it will perform B first and then perform A. A. There are other instructions you can give to an affine transform, and we'll be looking at those later, but they will always be performed in the opposite order that you give the instructions to the transform.